Hello, this is Jason. Thanks for joining us today on session 8. Here we're going to be covering route redistribution. How does OSPF deal with redistribution or external routes? This is the 8th session. We're getting towards the end of Practical OSPF for Network Engineers. As always, if you like the content that we're producing, just give it a thumbs up. If you'd like to be notified when we have new uploads, please hit the subscribe button and then click on the little bell. It'll let you know anytime we upload content. Also, if you'd like to reach out to me, maybe request a topic or have some questions, or you'd like a copy of the slides or anything else, my email is at the bottom. Let's hop right in. As mentioned, we're covering route redistribution. I think this is a huge strength for OSPF. It's probably my favorite protocol. Definitely my favorite internal protocol when it comes to route redistribution. And it's just because it deals with it, in my opinion, in a very elegant way, right? So first, let's just talk about route redistribution in general. And there's a lot of people out there that'll tell you never want to redistribute, or you just redistribute whenever you need to redistribute. There's a lot of opinions. None of them are necessarily wrong. None of them are necessarily right. You need to kind of wade through them. But here's what I would say. The challenge with redistribution in general is one of metric. It's a mathematics problem, really. These different protocols basically build their metrics in different ways, and there is no math in the router itself that allows you to get from one protocol to another. Think about OSPF and EIGRP. Now, EIGRP is going to be the cumulative delay and the lowest bandwidth is how it's going to compute its metric by default. I'm not talking if you adjust K values or anything. And then what about OSPF? Well, OSPF is its cost is based really on the reference bandwidth, right? Which hopefully we've changed. There is no way for the router, I'm not saying maybe a mathematician couldn't do it, but there's no way for the router to go from cumulative delay and lowest bandwidth to additive bandwidths based on reference bandwidth, right? It just doesn't work. And so it's always a challenge, right? And this makes the challenge really one of path selection, taking suboptimal paths or getting things like routing loops, etc. But the good news, like I said, in my opinion, OSPF has a really elegant solution for this. The other challenge, and we touched on this in the last section, is what do we allow in and what do we allow out, right? And just a spoiler alert, I always recommend strict filtering in both directions. Have a prefix list and a route map on your ASBR that strictly controls what comes in and out of the protocol. That's my opinion. That's how I do it. Have done it for over 25 years. Let's talk about the mechanism within OSPF. They have something called an external type 1 and an external type 2. The first thing to be aware of is if you don't do anything, if you just did a redistribute EIGRP 100, you will get an E2, right? But for purposes of our example, we're going to do both. R3 is going to bring in an E2, and R2 is going to bring in an E1. And they're both going to come in with a cost of 100. So we could say I set up a prefix list and a route map. In the route map on R3, maybe I set the metric type, maybe I don't, maybe because it'll default to E2. But I set the metric and I set the metric to 100. So when those E2 routes come in, they come across that cost 30 link. They get the R1, but they're still at cost 100. And that's what an E2 is. It comes in with whatever cost you assign it, or a default cost, and it never changes after that. It always stays with the cost that you brought it in as. However, with an E1, when I bring that in, and again, it's going to come in with a cost 100. In this case, it crosses a cost 60 link. It's going to land on R3 with a cost of 160, meaning it is going to adhere to the shortest path first algorithm for costing. And that's why an E1 is always preferred over an E2. So why do I like this so much? There's two reasons. The first is I don't like it when we deal with changing things like administrative distance. That seems like too heavy-handed of a methodology for me. So I like that we're sticking with the same administrative distance for both of these. The other thing is I can now bring in routes via two different routers, R2 and R3, and always prefer the E1s over the E2s, but seamlessly fail over to the E2s if I need to. Right? So why would I want to do that? Well, I've got this redistribution going on. Let's say R2 has a circuit, like a DIA circuit or something that goes to that EIGRP router. But R3 is maybe using like an LTE link or a satellite link, and you might be paying per megabyte or per gigabyte or something like that, right? So I never want to take R3 unless I cannot take R2 for some reason, right? So with the mechanism that I always prefer an E1 over an E2, I will always take that R2 path as long as it's available. When it's not available, I'll take the R3 path, right? But I'm not spending extra money. For example, like I said, if it's a fee usage type circuit, I don't pay extra for it. And that's why I kind of prefer the redistribution mechanism here in OSPF. Hopefully that made sense. What are some best practices? Well, as I mentioned at the top, always filter in both directions. Set a prefix list and a route map for what you want to allow in and what you want to allow out. Always set a metric and a metric type. Even though E2 is the default, I always just set it as an E2 if I want it as an E2. I don't know, maybe this is just something as I've gotten older, but I like doing that explicitly because when someone looks at it, to me at least, and that might be a bias, to me at least, when someone looks at it, they're going to say, oh, they really meant for that to be an E2, right? If there is no metric type, you might be confused as to, did they mean for that to be an E2, or did they not know that there's a difference between an E1 and an E2? And I like to set the metric and the metric type in a route map. So if I need to change them, I just change it in the route map and it applies to the prefixes that are being redistributed. I'm a big fan of route maps in general, so I leverage them as best I can. And then lastly, and this is true across all configurations on your routers and switches, but to me, name your objects in a meaningful way, right? What do I mean by that? Well, for example, if I'm redistributing OSPF into EIGRP, I could name my prefix list and route map OSPF into EIGRP. And for me, when it comes to redistribution, I make the prefix list and the route map match if I can, if it makes sense. Sometimes it doesn't, but in general, that's my recommendation. That's it for today. I think next session, I'm not sure yet if we're going to do a lab on the next session or if we're going to do one more wrap up with some bits and bobs that we haven't covered yet. I'm still trying to figure that out. Thank you for your time today. It is always appreciated here at Net.Academy.
Need help? Call our cybersecurity team and book a consultation with us today.